Okay, so we are looking at section 5.3, and in section 5.3 you are solving trig equations. All right, in this section, to solve, your first step is usually going to be to isolate the trig function, and goal number 2 or step number 2 is going to be to solve by using your knowledge of the unit circle. So feel free to take out your unit circle right now as we are going over this. I know you have them memorized, but it might be good to have it out in front of you. And we're going to be using algebraic techniques like combining like terms and factoring.
We did our 5.1 question.
Yes, as soon as I get everybody, as soon as I shake down enough people to take it. All right, got a few people that still need to take it. Okay, so let's take a look at number 1 on your gift. Whoopsie, that's not what I wanted to do. Oh, that was weird.
Which gift?
That was weird. The first one, the one that doesn't say B. All right, so let's take a look at number 1. It says solve 2 sine x equals 1. So our first step here is going to be to divide both sides by 2. And so we're going to have sine x equals 1/2. All right, so now you're going to look at your unit circle, and you're going to say, where on my unit circle is the sine equal to 1/2? And where would that be? Madeline?
Pi over 6.
Pi over 6. Pi over 6 is here. And the ordered pair is square root of 3 over 2, comma 1/2. So yes, the sign is 1/2. Anywhere else? And
5 pi over 6.
5 pi over 6 is here. And again, the y coordinate is 1/2. All right. So our solution is x equals pi over 6. X equals 5 pi over 6. But wait. Can't I wrap around like a whole extra time and still get to another angle whose sine is going to be 1/2? Okay, and then I could wrap around again and again and again. So we want to generalize our solutions. We're not just going to say pi over 6, comma 5 pi over 6, dot, 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 right? We're going to have to generalize. So we want to say pi over 6 plus 2 pi n, because every time we add 2 pi or 4 pi or 6 pi or 8 pi, we're going to get back to this same place on the unit circle. Everybody with me? Yeah, so in this case, we're going to say pi over 6 plus 2 pi n, and same thing, 5 pi over 6 plus 2 pi n, where n is any integer. Okay? All right, let's take a look at number 2. Here we are solving. Here we are solving sine x minus square root of 2 equals negative sine x. What do you think our first step could be here, Sammy?
You can subtract the sine x on the left to the negative sine x on the right.
So you want to subtract sine x from both sides?
Or you can add the one on
Let's go with your first idea. So let's subtract sine x from both sides. So we get negative square root of 2 equaling negative what?
2 sine x, 2 sine of x.
Negative 2 sine x. Everybody agree with this? Then what could be our next step here? Nick? We're trying to get to sine x by itself.
That would be dividing by -2.
Let's divide both sides by a -2. So I end up getting sine x equaling negative divided by negative is positive, square root of 2 over 2. Now you look at your unit circle and you say, where on my unit circle is the sine equal to square root of 2 over 2? Brendan?
Pi over 4 or 3 pi over 4.
So pi over 4 is here, and 3 pi over 4 is here. Does everyone agree that those are the places where my y coordinate is square root of 2 over 2? Are we okay with this? All right, and to write our solution then, we're going to write x equals pi over 4, but we want to generalize, so what's this going to look like? Arya?
3 pi over 4 plus 2 pi n and pi over 4 plus 2 pi.
Pi over 4 plus 2 pi n?
Yeah.
And we need to keep that phrase there also where what?
Where, oh, n equals, or n equals any integer.
Where n is any integer. Are we okay with this?
We always have to write where n is any integer.
You have to always write that unless we get to, may I borrow? Unless we get to problem number 5, 6, 7, 8, 9, where they say find all the solutions in a set interval. Then you can just list the ones that work and stop. You don't have to generalize. But if you do have to generalize, then yes, you need to keep writing that phrase. Okay, what about number 3? It says you're solving, come on. You're solving 4 sine squared x minus 3 equals 0. Talk me through this one, Zach. What should we do first?
Should add 3 to the other side.
All right. Adding 3, then what?
Divide by 4.
Dividing by 4, and I get sine squared x equaling 3/4. Then what should be our next step, Anna?
Then we would take the square root of each side,
And what do we need to remember when we take the square root of each side?
plus or minus.
Plus or minus. So we should have sine x equaling plus or minus square root of 3 over square root of 4, which is equal to 2. So I get plus or minus square root of 3 over 2. So where on our unit circle is the sine equal to square root of 3 over 2 or negative square root of 3 over 2? Brendan?
For the positive square root of 3 over 2, that would be 2 pi over 3 or pi over 3.
Okay, 2 pi over 3 is here, pi over 3 is here. Those both have a y coordinate of square root of 3 over 2.
And for the negative square root of 3 over 2, it would be 5 pi over 3 and 4 pi over 3.
There's 5 pi over 3 is here, 4 pi over 3 is here, and those both have a y coordinate of negative square root of 3 over 2. We needed both of those, right? Okay, so do we need to list all 4 of these separately and write plus 2 pi n after each one?
Yes.
Sydney, you're shaking your head now. How can we simplify that? How can we make it so we don't have to write 4 different equations or solutions?
Just write 1.
Anna?
Wouldn't you could do like the x equals pi over 3, and then you can do plus pi, and
Y plus pi n.
because then you find your other like halves, like 'cause we go exactly
Right,
pi.
That would get us
180 degrees.
Okay, so that would advance us 180 instead of 360 degrees. So that's going to add just get us to the opposite side of the unit circle.
Yeah.
So if we do pi over 3 plus pi, we get to 4 pi over 3. Plus pi again would get us to 7 pi over 3. Plus pi again would get us to 10 pi over 3. And does this make sense?
So we have to write plus pi.
All right, so what we're going to write is we're going to write pi over 3 plus pi over 3 plus pi n, where n is any integer, and x equals, can we do the same thing with the 2 pi over 3?
Yep.
So 2 pi over 3 plus pi n instead of 2 pi n, right? Where n is any integer. Are we okay with this? Let's take a look at the next one. For number 4, we are looking at solving sine squared x equals 2 sine x. Ideas on what to do here, Vincent?
You can divide by 2.
If we divide by 2, we'll end up with a fraction on the left. Dan?
I was going to divide by sine x on both sides, so that way we can get just down to sine x on the left side.
All right, if we divide both sides by sine x, let's see what happens. The sine x here divides out with one of those, that divides out with this, and we're left with sine x equaling 2. Agreed? Where on our unit circle is the sign equal to 2? Why not, Charles? All right, sign's biggest value is 1, smallest value is what? Negative 1. So sign value never gets to 2. So right now, this is no solution. But guess what? This equation does have a solution. So I think that Dan's idea of dividing by sign may have cost us some solutions and lost some solutions for us. So instead of dividing by sign x, can we try something else?
Take the square root.
Not taking the square root. Other ideas? Anna?
Factoring.
Oh, maybe we need to do something before we try factoring? Like, I like the factoring idea, we definitely want to use that.
Identity?
Inverse.
Kathleen?
Subtract 2 sin x from both sides.
All right, let's do that. Let's subtract 2 sine x from both sides. And that's going to get us sine squared x minus 2 sine x equals 0. It's pointless to factor unless you have 0 on one side of the equation. Because the whole purpose of factoring is to get a product of 2 or more things equal to 0, so one of them has to be 0, right? In this case, what can we factor out here? Sine x. So if I factor out a sine x, what's going to be left when we factor here?
Is this stuff on the test, right?
No, it is not. Hannah Taylor.
Sin x minus 2.
So I get sine x minus 2. Remember, now I've got 2 things being multiplied together to give me 0, so one of them has to be 0. Either sine x equals 0 or sine x minus 2 equals 0. Well, this one over here, we already know what happens when we add 2 to both sides. We get this, and we say, hey, no solution. I'm abbreviating. Right? But what about this one? Where on our unit circle is the sign equal to 0? Brendan?
0 or, it's 0 at 0 or pi.
0, which has the order pair 1, 0, or you're saying at pi, which has the order pair negative 1, 0. Everybody agree with that?
Yes.
If that's the case, then we can list our solutions. How? What are we going to write for our solution for this, Max? Because we have to generalize, right? 0 plus pi n, where, all right, any integer. Okay, and really if it's 0 plus pi n, we probably could leave that part out, right? Because 0 plus pi n is just pi n. Are we okay with this? All right, let's take a look at number 5. This time you don't have to generalize because it says we're only looking for our solution between 0 and 2 pi. By the way, if 2 pi works as an answer for this, we're not going to list it because 2 pi is not included. 0 is included, 2 pi is not. Everybody agree? So in this case, what are we going to do to solve this? Dan Bach. Ideas?
Well, we could get, trying to think, maybe get signs on different sides of the equation. Because then you can't, I don't think we can
Having
factor yet.
0 on one side is a valuable thing.
But can we factor with that 1?
Why not? Product sum. Let's do product sum. Product would be 2 times 1 is 2, and the sum is negative 3. So what 2 numbers will work here in the product sum technique, Sydney? Negative 2 and a negative 1. Do people agree? So we're going to take out this negative 3 sine x and replace it with a negative 2 sine x and a negative 1 sine x. So it's going to look like this. 2 sine squared x minus 2 sine x minus 1 sine x plus 1 equals 0. Can you help me with the factoring step here for factoring by grouping, Kathleen? 2 sine x is what you're factoring out, times what? Sine x?
Oh, no.
Just sine x?
Minus 1.
Minus, do people agree with that? And then keep going, Kathleen, what about here?
Factor out sine x.
There's no sine x here.
Factor out 1.
1 or negative 1? Your choice. Negative 1, and then what's going to be left in parentheses? Sine x minus 1 again. So our final factored form is going to look like what? Mia.
Sine x minus 1 times sine x.
Everybody agree with this? All right, and at this point, you know what to do. You would set this equal to 0, you'd set this equal to 0, and you'd solve. I'm going to put a dot, dot, dot on this one because I want you to finish this one up later. All right, right now, let's take a look at the next one. For number 6, whoa, what happened here? Why is this one more difficult than the others? What's wrong?
They broke it.
They broke it.
There's two different trig identities.
There's 2 different trig identities, which I don't know if that means broke. I don't know. Anyway, what are we going to do about that? Skip it? Identities, thank you. What identities could we use to help us out?
Oh, you could do 1 over cosine and sine over cosine.
I would think that there's an identity that gets you from secant squared to tangent squared or vice versa. What would that be, Sammy?
Like, tangent squared is like the secant minus, the secant is squared minus 1. Or
All right.
Plus 1.
So secant squared is equal to, wait, is it 1 plus tangent squared?
1 plus.
All right, so we could maybe make that substitution. Plug in, take this secant squared out, and replace it with 1 plus tangent squared. So we're going to have 3 times the quantity 1 plus tangent squared x minus 2 tangent squared x minus 4 equals 0. We distribute the 3. We get 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 equals 0. Can you clean this up for us, please? Hannah G?
3 plus, or no, negative tangent squared x minus 1.
Tangent squared x minus 1 equals 0. Then what's going to be the next step here, Charles?
Oh, you, yeah, no, I don't know. Minus 1,
Well, it's already minus 1.
I mean, so add 1.
Add 1 to both sides, so we get tangent squared x equals 1. Then what, Charles?
Then you, square root of tangent.
Take the square root of both sides. What do we need to remember when we take the square root of both sides?
Oh, it's plus minus.
Plus or minus.
Tangent x equals plus or minus square root of 1 is
All
not
right,
1.
so tangent x equaling plus or minus square root of 1 is 1. So where on our unit circle,
Oh, that's at like pi over 1 pi, 2, no, 1 over 4 pi.
huh? Who's that, Charles?
Sorry, 1 over 4 pi, right?
Pi over 4?
Pi over 4. That's what I meant. 2 pi over 4.
I know what you meant. All right, where
Pi
else?
over 4. 2 pi over 4, which is pi over 2. Then that, like, it's like 3 pi over 4. Yeah, no, I know.
Are people agreeing?
No, but that one was off by 1. I drew it off.
You don't want this one?
No, the third one.
Charles does want, you don't want this one?
It's off by 1 and it's like just bothering me a little.
He wants you to redraw is what he's saying. He wants you to redraw.
No.
Oh, you're awful, man. No, the wrong dot.
Joe,
It's even worse.
oh, did I not even put it the right place?
Yeah.
It's bothering me a little.
That's on me. Okay, so like this?
Yeah.
All right, are we okay with these?
No.
What's wrong, Dan?
Well, 1 divided by 0 is nothing.
You're saying over here, the ordered pair is 0, 1, and 1 divided by 0 is undefined, so it's not equal to 1 or negative 1?
Correct.
So we need to get rid of that
That's
one?
why when I said 2 pi over 4, I meant the other one.
Gotcha, so we got pi over 4 and 3 pi over 4.
And then you would have,
Any more?
it's 5 pi over 4 and 7 pi over 4.
5 pi over 4 and 7. I gotta say, in my own defense, this board is really nice, but it doesn't have lines drawn into the pi over 4.
Yeah,
Which-
no.
okay, but it's still
I
nice. Okay, anywho, all right, so these are our solutions. Are we supposed to generalize? Or just list the ones between 0 and 2 pi? Just list, all right, so that means our solution here is going to be x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Are we
Why
okay
don't
with
you do
that?
the other thing?
Yeah.
Plus,
Why
There's
can't
an
we do
interval.
pi over 4 plus pi
like
times n?
2 pi.
Because then it would still be pi over 4.
I thought we didn't have to generalize for this one.
Well, why not?
No.
But
Is that just
there's
a thing?
4.
No,
You guys don't. Oh,
is it only saying between 0 and 2 pi?
Yeah.
Okay. Let's take, hang
I don't
on,
even have the paper in front of me.
why not? Do you need one of these?
No, oh, yeah, I found it.
How did you
If it did not say between 0 and 2 pi, and you did have to generalize, would we have to list 4 different equations?
No.
Kathleen, what could we do?
X equals pi over 4 plus 2 pi n.
Plus 2 pi n?
Yeah.
That would just give us all the ones that end here.
Pi over 2.
Pi over 2n?
Yeah.
Pi over 2n is 90 degrees, right? So if we just say pi over 4 plus pi over 2n, that's just going to advance us exactly 90 degrees, which is what we would want. So if you were to generalize, then we'd write x equals pi over 4 plus pi over 2n, where n is any integer. Agreed? Are we okay with that? I mean, it's not going to be wrong if you say plus 2 pi n each time, but certainly not efficient. Okay?
What did you have to write a domain for it? Because it's 0 and 2 pi. No, just like it's at 1.
If it didn't say between 0 and 2 pi,
What
then
does
we would
answer
write that.
if you like write a domain with it and write it that way, but then say like, and then just write a domain?
I don't know what you mean.
Well, you just write that equation, but then you'd write the domain next to it, and that'd be like the answer.
Like, and then the limit, so we go from pi to not including pi.
Like, you know,
Instead of like, and listing the individual.
Instead of where x
Well, you'd have to limit the domain.
where x equals any integer between.
That's way too complicated. Why can't you just write the 4 answers and call it a day?
I would just write the 4 answers.
Okay, we were just asking.
Yeah, I would just write the 4 answers here if it's satisfying them between 0 and 2 pi. Did that answer your question?
Wait, but would it be marked wrong? Like,
If you wrote this?
With a
and then
domain.
instead of writing this as an
Oh.
integer, we just add it to the
Yeah, I want you to actually find the forms. So I would like you to list them. Okay, let's take a look at the next one. This is the first one that I think actually kind of calls for a trick. I mean, I'll refer to it as a trick.
Oh, it's easy.
So like something we have to memorize, like trick is in one type of trick.
A trick as in a strategy that we have not used in the first 6 problems. All right?
Makes it a lot
Is it a
easier.
magic?
Oh, what strategy would you use?
I would use I use Pythagorean identity.
Yeah.
Sure
They're
can.
not
You can square everything.
No, you can't.
Yes, you
Oh, okay. Let's back up. I don't know where you're going with the Pythagorean identity, but I do think. Oh, I think maybe I do know where you're going with this.
Yeah.
But I think I would say your strategy is to square both sides. That's the trick that I think that we need for this problem. Is that we would square
You
both
deserve the
sides.
pep.
I do deserve a pepper for that.
Because
Nice.
I'm a crook.
Vincent was trying to say-
Wait, but are we able to do, like, do we know that that this is like a real, I know before we like couldn't do that.
Divide by sign, we couldn't do that.
I know, I know, like, what's on both sides.
Let's talk about that. Remember in the example number 2 or 3, whatever it was, we tried to divide both sides by sign and we ended up losing potential solutions, right, by doing that? But here, we're squaring both sides, so if you can recall back to, I don't know, late August, early September, when we were in the appendix, and we talked about what happens if you're trying to square both sides of a radical equation, you might be introducing what kind of solutions? Extraneous. So we're going to need to check our solutions here to see if they work. All right, so let's square both sides. You know that that means we're doing sine x plus 1 times sine x plus 1, right? So I got to use FOIL. I get sine squared x plus sine x plus another sine x is 2 sine x plus 1 equals, and cosine x quantity squared is the same as cosine squared x. Everybody agree? Okay, at this point, I have a problem. I got one equation with 2 trig functions. Can you help me out? What do you think, Sammy? All right, which identity would you use?
Sine plus cosine is equal to 1.
Sine squared?
Or sine squared plus
Sine
cosine
squared plus cosine squared is equal to 1. That means I can take, whenever I see cosine squared, I could rewrite it how?
It equals.
By the way, when we have our test,
It
you need to
equals-
have all of these identities memorized. You need to have all these identities memorized, right?
1 minus, oh god.
So what is it?
One
sine squared minus
1 minus sine squared x, right? So I have sine squared x plus 2 sine x plus 1. So I think now to solve this, I might subtract 1 from both sides. They're subtracting on.
And then you add
Add
you could add
sine squared
to
x.
the other side. You have to
I'm
do
adding sine squared x to both sides, so I can get 0. Do I get 2 sine squared x plus 2 sine x equals 0?
You can
Agree?
divide both sides by 2. Is that a thing?
Yes, you
You
could.
get sine squared x plus
Yeah, it's okay to divide both sides of an equation by a number. It's when you divide both sides by a variable expression, like, divide everything by x plus 2, or divide everything by sine x, that you end up losing solutions. So dividing everything by 2 is fine. So we've got sine squared x plus sine x equals 0. Now what?
Now you do this.
I heard it. Factor. So we're going to factor out of sine x, and it's going to be sine x times what? Sine x plus 1. All right, now I got 2 things being multiplied together to give me 0. So let's actually do this. Because remember, we need to be checking for extraneous solutions when we're done, right? So if I take sine x equals 0, and here I get sine x plus 1 equals 0, right? Or in between here. Where on our unit circle is the sine x equal to 0? By the way, is this only between 0 and 2 pi? Yes? Okay, so tell me, Joe, where is the sine equal to 0 on our unit circle?
0 and 5.
At 0 and pi, do people agree with that? All right, that's here and here. Okay, so I get 0 and pi. And what about this one? If I subtract 1 from both sides, I get sine x equals -1. So where would that be on our unit circle? Madeline?
3 pi over 2.
At 3 pi over 2, do people agree with that?
Yes.
3 pi over 2 is down here, and that order pair is 0, -1. So we're adding 3 pi over 2 to our list. But we need to check all of these in the original equation. If you're born in the month of January, February, March, or April, can you plug in 0? January through April, you're plugging in 0 into the original. Where's my original? Which is sine x plus 1 equals cosine x. Go ahead and plug in 0. If you're born, let's see, May, June, July, August, can you plug in May through August? You're going to plug in pi into the original to see if it works. And if you're born September, October, November, December, you're going to plug in 3 pi over 2. And I want to know, do they all work? Yes, no, where are we plugging? If you don't plug them into the squared one, you're only going to plug them into this, right?
the special. I got one is, I got the pi one is negative.
I got false. Yeah, me too.
Which one is false?
The pi one.
Pi?
I was born.
We try pi, so this is sine pi plus 1. This is us checking. Is that equal to cosine of pi? Well, sine of pi is 0. So I get 0 plus 1 equals cosine of pi is negative. Oh, no good, right? So this pi value here is extraneous, right? Extraneous. Do the other two work?
0 works.
0 works? Because we're trying sine of 0, what is it? Sine of 0.
Plus 1 equals cosine of 1.
Thank you. Sine of 0 plus 1 equals cosine of 0. Sine of 0 we said was
0.
0 plus 1 equals 1. That one works. All right, so we like this one. How about the 3 pi over 2? Does it work? Sine of 3 pi over 2 plus 1, is that equal to cosine of 3 pi over 2? Sine of 3 pi over 2 is negative 1, right? Plus 1 should equal 0. Is that what the cosine of 3 pi over 2 is? So that one works. So we like this one and we like this one as our solution. So x equals 0 and 3 pi over 2 are the only solutions that work. Pi is extraneous. Are we okay with this? Let's see. Okay, now we get into something a little bit different because this one has not the sign of x but the sign of 2x. So we're going to need, I won't even call it a trick, I'll say we need a strategy for this, okay? And the strategy here is going to be to make a substitution. Let's let u equal the 2x. And then we're just going to solve for u. So in this case, we're going to have sine u minus square root of 3 over 2 equaling 0. And let's add square root of 3 over 2 to both sides. So I get sine u equals square root of 3 over 2. Now, before we go looking for these solutions on our unit circle, can we all agree that we are supposed to be finding all values of x between 0 and 2 pi? Correct?
It's not greater than equal to.
Thank you. You got me? Thank you. All right, and if that's the case, I wrote it correctly this time, but we have u instead, and u is 2x. So let's multiply all of these by 2, so we can get a 2x there. So I get 0 is less than or equal to 2x is less than what? 4 pi. That means this 2x is really u. So that means that instead of looking just on the unit circle between 0 and 2 pi, we need to look on the unit circle between 0 and 4 pi. All right, so let's
Mine has been blown.
start with that. That's my job, I guess. All right, so sine of what angle is going to be equal to square root of 3 pi, square root of 3 over 2, Anna?
Pi over 3.
Pi over 3.
Would it be u equals pi?
U equals pi over 3. That's 1/2 comma square root of 3 over 2. Where else, Anna?
It'd be 2 pi over 3.
2 pi over 3, which is negative 1/2 comma square root of 3 over 2. Where else? That's it between 0 and 2 pi. But we have to go, remember we're finding u right now, so we got to go all the way around to 4 pi. So we got to wrap around one more time, Dan.
7 pi over 3.
Because you're saying if I wrap around like this, I get to 7 pi over 3, same place. And where else?
Let's go 3 pi. 9 pi over 3. Wait, no, not at all.
3 pi is going to be over here.
8 pi over 3.
8 pi over 3, I would agree with that. Are we okay with this? Because that's also at the same place.
Is it 9 pi over 3?
No, 9 pi over 3 is over here. At same place pi is. We don't want that.
Oh, I totally get it.
All right, so let's talk about what we found. We found that u is going to be equal to pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. Is that right? But that's u. We're trying to find x. And we know that u is equal to 2x right? So to solve for x, we're going to have to do what? Divide everything by 2, or multiply everything by 1/2, however you want to think about it. I like to do it that way. It's just, I think, easier. So if I'm trying to get x, right? So now I have x equaling pi over 6. What else? Pi over 3, because that's 2 pi over 6 is pi over 3. Then what? 7 pi over 6. Then what? 4 pi over 3. These are our solutions because now I've solved for x instead of u. And are all of these between 0 and 2 pi?
Yes.
Yes. Are we okay with this?
Yeah.
All right.
Wait. Are we on the quiz now?
We're running out
Take
of
the
time.
quiz. Almost forgot about that, huh?
Oh my God.
Charles,
come
back, Charles.
Come back. And you just decided to start talking about our name.
Listen.
Next time.
Don't, you know.
Gosh, you're making my leg hurt.
We're going to take that quiz in about 2 minutes, but I just want to get you started and set up on this one, because this one we're going to have to also make a substitution. Let's let u equal x over 2 this time. So that means we're really solving tangent u minus 1 equals 0. Add 1 to both sides, we get tangent u equals 1. But where should we be looking? Between 0 and 2 pi, 0 and 4 pi, where are we looking? Well, remember, we're looking for x between 0 and 2 pi, but we really want to know, what about x over 2? So let's divide everything by 2. So it's just between 0 and 2. So we're really, whoops, and this is equal to u, right? So I can rewrite x over 2 as u. So I'm looking for u between 0 and pi. So where between 0 and pi is the tangent equal to 1? 4 over pi. I'm only looking between 0 and pi.
Pi over 4.
Pi over 4.
That's it.
Pi over 4, that's it? So our answer here is u equals pi over 4. But I didn't really want u. U is equal to x over 2, so I can rewrite this as x over 2. And then what am I going to have to do to solve for x? Multiply by 2. So if I multiply both sides by 2, I end up getting x equaling pi over 2. And that should be our only answer for this problem between 0 and 2 pi. Right? You could plug in pi over 2. Pi over 2 divided by 2 is pi over 4. Tangent of pi over 4 is 1. 1 minus 1 is 0. It works. All right, Anna.
Do we only have to check for extraneous when we do things such as squaring both sides?
Yeah, I mean, it's probably a good habit to check your answers anyway, but that's the only time you might be introducing the trick.
For number 10, we are going to setting it equal to 0.
I would. I'd subtract a 6 over and then do product sum. Okay, let's take our ACT quiz. Thank you to Charles for reminding me.
Yeah, good job.
Good, Charles.
You
You don't have to take a quiz for that.
All right, let's see.
That's just racist.
It's not racist. There's nothing racist about it. That was unnecessary.
Charles, you're better at throwing than catching.
Yeah, I'll catch it. I'll catch it. Perfect, thank you.
Normally it's the other way around.
Where did you find it?
Actually, these were a gift from Mr. Valley for Christmas. She gave all the math teachers. Isn't that cute?
Can you tell her to get me a Christmas present next Christmas? I love these.
These are my
You literally-
favorites. I have actually,
Yeah.
Charles, fear not, I have another bag of these at home though.
I will buy them.
Okay. All right, let's see.
Yeah,
You guys have a little wall you can put up there?
Oh, Miss Spencer, use it up and see over here.
And
right here. And right there.
What's all right?
Right there. I'm just filling out my
No, I was confused before I wasn't there.
Yeah, you know, hey, let me just see what this
Isn't that, these are calculations.
Yes. I was gonna lie.
Thank you.